In the previous video, we used the formula for the sum of the terms of an arithmetic series to solve some problems, but now let's actually derive the formula in order to get a better understanding of it. And there's an interesting story about the mathematician Friedrich Gauss that when he was a schoolboy, he was kind of bothering his teacher because he was much better at math than his teacher, and in order to get him to go away, the teacher told him to add up the numbers from 1 to 100. And to the disappointment of the teacher, Gauss thought about it for a couple seconds and came back with the right answer. And the story goes that he used the method that we're about to look at to figure that out. So I'm going to call this Gauss's method. If we want to find the sum of the series from 1 to 100 inclusive, using Gauss's method, we're looking for the sum of the first 100 terms. So let's just write out 1 plus 2 plus 3 plus ... plus 98 plus 99 plus 100. That's what we want to work out. And what Gauss did in his mind is he took this series and he reversed it and thought about writing it backwards underneath here. So he wrote 100 plus 99 plus 98 plus etc. And then on this side we would have 1 plus 2 plus 3. So this is the sum that we want, one row, but now we've actually doubled that, written it backwards in the row underneath. And if you take a look here, we can divide this into columns. And what's interesting when you look at the columns is that each column adds to 101. There's a symmetry here. Now, how many columns do we have? Well, we've got a column with a 1 at the top, a column with a 2, all the way up to a column with 100. So we've got 100 columns. So we have 100 columns, and each column totals 101. That means that the total of all of those numbers is 10,100, just 100 times 101. But we've got 2 rows, and that's twice as many numbers as we want. We really only want the sum of one row. So if we take 10,100 and we divide it by 2, we get the correct answer, the one that Gauss came up with in his head, 5,050. So there's a neat method for figuring out the sum of an arithmetic series by writing it backwards and then adding the columns, then dividing by 2. Now let's use the same approach to work out the sum of any arithmetic series. Remember that the general term of an arithmetic sequence, and therefore also of a series, is any term is equal to the first term plus n minus 1 times the common difference. So if the first term in a series is a, the second term is going to be a plus the common difference. The second one is going to be a plus 2 common differences, etc. All the way up to the last term, which is going to be a plus n minus 1 common differences. If this is a series, then we're just adding these all up together. And I'm going to put a little ... here. This is the same as what we were doing above, 1 plus 2 plus 3 plus etc. Now, if we want to write that backwards underneath, this one over here, the rightmost one, is going to be a. The one next to that in this space is going to be a plus d, then a plus 2d, etc. ... The one all the way here on the left is going to be a plus n minus 1d, the last term in the series. The term before the last in the series has one less difference added to it. One difference less than n minus 1 differences is n minus 2 differences. So the second to last term in the series would be a plus n minus 2d, and the third to last term in this series would be a plus n minus 3d. etc. Now we've got columns like we did in the previous example. And in the previous example, all the columns added to 101. In this example, all of the columns add to a plus a is 2a plus n minus 1d. And you can go through these and verify for yourself that they add up to 2a plus n minus 1d as well. So now we have columns that all add up to 2a plus n minus 1d. Now, how many columns do we have? We have that many columns. That's the number of terms in the sequence, or in the series rather, which is n. So we have to multiply by n. This number in the previous example was 100. We had 100 columns and we were multiplying by the sum of each column, 101. Now we have n columns and this is the sum of each column. But remember that we've got twice as much as what we wanted, so we have to divide by 2 so that we only have one row instead of the 2 rows. So that's where we get our formula for the sum of the terms of an arithmetic series. S sub n is equal to n times 2a plus n minus 1d all over 2.